Hi, I'm Jim Noble. I'll be your instructor today. We'll either learn something or you'll get a good nap. That's qualifications of an instructor, is if I can put you to sleep or teach you something, then I've done my job. So stay with me. We're going to go over the electrical portion of the AC on this 2000 Chevrolet Silverado. Now first, we're going to remove our electrical panel cover, and underneath the cover is our fuse diagram. And here's an overlay of the fuses. And this is the area we're most interested in. Notice some of these relays look like they're upside down. It doesn't matter on these relays which way they're put in, they'll work either way. If you want to know why, just drop me a line. Now I had somebody recently ask me, he said he could jump his relay over and his compressor clutch would run, where to go from there. And that's what this video, that's where we're going to start this video, but we'll be a little bit further in there than that. Now there's two ways to achieve this. Let's look at our wiring diagram, or our schematic. Now if you notice in our schematic, you can either jump from 30 to 87, or you can jump from 86 to 87. Either one of these will cause it to engage the clutch. Now you want to be cautious when you do that and make sure you got a heavy enough wire. If you don't, that wire is going to get hot and it could burn you. Now let's take a look at the overlay. You can jump from 30 down to 87 or 86 down to 87. This is our ECM. I don't know if you can see that or not, but you don't want to jump either one of these hots down to the ECM because you're going to blow a fuse. And if your ECM is old and weak, guess what? You'll need ECM. Now 86 goes to ignition E, 10 amps, and 30 goes to our AC. So that's where our two fuse locations are. Now by doing that, we've proven, or he's proven, that he's got everything except for his relay control from the PCM. So it's on the PCM side. We'll take a look at that. Now let's move back to our wiring schematic. So here's the issues that the ECM that we can check. Our high pressure cutout switch. Now it's going to be located on the bottom, on the back of the compressor. And for it to work, we're going to need it to be a closed circuit, so you can take your voltmeter and set it on resistance, and you should get a very low resistance reading. Or you can set it on 20 volt scale and you should get right at 0 voltage. We go down to our low pressure cycling switch, where everybody knows it's mounted on the accumulator, and do the same thing. And we're going to put our meter on both these prongs, and we're looking for a 0 voltage drop, or you need your power to be off, very low resistance reading, 0.7 or better. Voltage, we want it to be less than, I'm going to say 0.5 volts. And our automatic recycling switch, which is located on the high pressure side right beside your radiator, and we're going to look for high resistance or 12 volt or system voltage. Now let's look at the connector view on the back of the compressor. Now we're going to come off of our connector view on the back of the compressor. What it's looking for is this to be shorted together by means of the switch. So the AC switch is pushed inside the car. It's going to send a ground. Now our light blue wire, which is A, and B is coming from the ECM. Unless it sees something wrong, these two should be shorted together. Common issue is either a wire broke at the compressor or it's unplugged for some reason. But unless it sees a catastrophic issue in the compressor, it wants this to be shorted all the time. Now we're getting a signal, so we're getting 12 volts out of the ECM. And then the light blue wire is going to be grounded as long as the switch is pushed and your head unit or your head is getting power. So if your light comes on, you should be getting a ground out of A. We're going to want a ground there. And then we should get 12 volts here. And if you do a voltage drop across them, you should get near 0. If you get any voltage, then that switch is probably bad. Now what's happening is the ECM is looking for 0. It's sending out 12 volts. ECM sends out 12 volts. It wants to see 0. Once it sees 0, then it deems this to be okay. Now with the ignition switch on plus AC on, now there's two ways to do this. The easiest way is to take and undo our connector and then put us a jumper wire between A and B. Start our engine and see if our compressor will run. If not, now to check this circuit just a little further, we'll get rid of our jumper wire, we'll get our voltmeter, and we'll come off of A and we'll go to a good ground. Set your meter on resistance, ignition switch on, AC on, should have less than 0.5 ohms. Now remember, you want this pigtail disconnected. Now this diagram shows A is a light blue wire, so you can check and make sure you're on the light blue wire, and B is dark green with a white tracer. Now we're going to move the wire off of A, put our meter on a 20 volt scale. Going to take the other end and move it to B, and you should see anywhere between 10 and 14 volts, depending on if your engine's running or you just got the switch on and how depleted your battery is. Now let's say A is okay and B is no good. We'll take a look at that circuit on the wiring diagram. Now we've narrowed it down in this area here. So we either got an open or a bad ECM. Now let's say B is okay and A is no good. Our problem is going to be between the control head. It's either going to be the control head or this light blue wire going to the AC switch is broke. Now what this circuit is done is the ECM is sending 12 volts out. It sees 12 volts here. This is sending a ground circuit out when the switch is turned on. Once this circuit is grounded, it'll see 0 volts here, which tells the PCM that it's okay to run the compressor. Now with the AC recycling switch, it works the same way. It's sending 12 volts down our dark blue wire, going, and it's located as if you're sitting in the seat, it'd be the right side of the radiator. It's looking for it not to go to ground. So we don't want that switch, we don't want to jump that switch. We're just going to unplug it, and if there's an issue in this area, then the compressor will run. It's just looking for high pressure at the high pressure line going into the evaporator. Now with our recycling switch, we're looking for 12 volts here and low resistance on our black wire. So our dark blue wire will have 12 volts and then we'll have low resistance there. If you do a voltage drop here and here, you should see 12 volts. If not, with this switch plugged in, then the switch is bad. Simply unplug it and see if your compressor starts to run. Now a high pressure cycling switch or recycling switch is located here. Now the purpose is to check the voltage. First we unplug it and see if our AC works. Now if not, we want to check our voltage to make sure that that wire is not shorted to ground. Now we want this switch to be working right, because if you have extreme high pressure, this will protect your system. So, but if you unplug it and the compressor starts back to working, then that switch is bad. Just replace the switch. Now with the sensor still plugged in, we back probe our dark blue wire. We should get in the neighborhood of 12 volts. The engine's not running. Battery can affect it, so you can check your battery voltage, see what you got. And also the ECM has a resistor built into it, so it won't be 12 volts with the engine off. Now this right here tells us that our switch is not shorted to ground. Now if we see high resistance here, we've got a bad ground or this wire is broke. Now at this point, we're not really interested in whether the black wire or ground wire has a low resistance, because it doesn't matter if that wire is broken or not. The AC, it will not stop the AC compressor from turning on, because think about it, it's looking for 12 volts, not 0 voltage. On this other circuit, if we see low voltage or no voltage problems between here and here. Now you got to remember battery voltage 12 volts plus, so always keep an eye on your battery. If you get a bad reading, recheck your battery and make sure your battery's not running down on you. Now let's look at our low pressure cycling switch. Our dark green wire should have 12 volts on it, or battery system voltage, and we should get low resistance on our black wire. If not, we're bad here or here. Now if you got any value out of this, I'd like for you to hit subscribe, and if you got any questions, drop a comment. I'll try to answer them best I can. Thank you for watching. See you next time.